All right, so we're going to look at the rest of the equations that we have not solved yet. Notice that this equation is exponential. 2 and 6 are not powers of the same base, so I need to take logs. It would make sense for me to take log base 2 of both sides, log base 6 of both sides, because either one of those would help us clean up one side of the equation. ln of both sides, because that would make the equation calculator ready, or log base 10 of both sides, again, calculator ready. We're going to work it two different ways. Let's look at log base 2 of both sides. Both ways of solving are going to give us similar kinds of math in them. Now, on the left side, log base 2 of 2 to the winds up canceling, leaving the x plus 5 only. On the right side, log base 2 of 6 to the, those don't cancel each other out. So remember, I asked you yesterday, make a note. When the log base 2 of and the 6 to the do not counteract each other, expand by dropping your exponent to the front, okay? Now, x times log base 2 of 6 is just a number. So I need to group my x terms on the same side and my non-x terms on the opposite side. If I want to solve for x, I've got to isolate a single x. So you factor it out as if x is a GCF. It is a GCF here, but even if it weren't the only common factor, you would still factor it out alone. Then I'm going to simply say, let me divide. Now, that is your final answer. There are multiple ways you could write that final answer. It would be a good idea for you on this one to get a decimal approximation, because it will be easier if someone else solved it a different way. If you all are comparing your homework, compare your decimal answers. Now, let's look at another way to solve it. You can also take ln or log base 10 of both sides. I'm going to take ln of both sides because I think that you'll see that more frequently in the rest of pre-cal and in calculus in college. Log base 10 is fine as well. Now listen, ln of 2 to the and ln of 6 to the, neither one basically cancel each other out. So in both of them, you've got to drop the exponent to the front. So it's all of x plus 5 in parentheses times ln 2, and it's x times ln 6. Now remember, ln 2 is just a number, so let's distribute. And I'm going to say x ln 2, put the x first, because if you put it last, it's going to look like you mean ln of 2x. That's not what you mean. Plus 5 ln 2 equals x ln 6. Okay? So I need all my x terms on the same side. How about I leave 5 ln 2 on the left by itself, and let's make x ln 6 minus x ln 2 on the right side. So keep in mind, 5 ln 2, if you wanted to make it ln of 32, 2 to the 5th, you could. You're not under an obligation to do that, though. Let's factor out x, and we'll have ln 6 minus ln 2. Again, you can leave it ln 6 minus ln 2, but do you see you could also make it ln of 3 by doing 6 over 2? So ln 32 over ln 6 minus ln 2 equals x. And again, if you made it x equals ln 32 over ln 3, this would be even easier to plug in your calculator. And look, you could also write that as log base 3 of 32. So do you need to do all of that? No. I'm just reminding you that there are multiple ways that you could write the answer. So you might want to play around with that a little bit. Be prepared for multiple ways of answering on a multiple choice test. And again, if you get the decimal approximation in addition to the no calculator answer, it might be easier for you to compare your answer to someone else's answer when your forms are different. Now we're going to jump to logarithmic equations. And just like if you have an exponential equation, there are two ways you can do the problem. If you have a logarithmic equation, there are two ways you can do the problem. Now, exponential equations type 1 is where you could get like bases. We're basically doing the same thing with logarithms. Now, your first rule is you never ever can leave double or triple logs on one side of the equal sign. So you always start by condensing. This is the step I need to see. Do not skip this step. If you do, I'll count a point off, and I want you to get that point, so show it. So once you have each side down to a single logarithm, it's a this and that rule. If ln of this equals ln of that, then this must equal that. Now that's not very mathematical sounding. It's more of a common sense step. Oh, look, I've got a quadratic equation. So I get everything on one side. First thing I'm going to see if it factors. I believe the AC method will work here. I'm thinking x plus 5 and x minus 2 work. So you're going to get two answers, but guys, with log equations, and this is new. So we know that logarithmic equations do not have domains of all real numbers. We know with logarithmic equations, logs only accept positive input values. Therefore, you must check for extraneous roots on logarithmic equations, okay? What you're checking for is to make sure that neither -5 nor 2 makes you take the log of a negative. But look, if I plug in -5, I have to do ln of -5, and I can't do that. So that's an extraneous solution. If I plug in 2, I can do ln 2. My calculator would accept that. And when I plug in 2 here, it makes me do ln of 5. I can do that. All right? So 2 is good. -5 is extraneous. Now here's another one that's going to be the same way. I can't have double or triple logs on one side of the equation, so I must condense. So log base 9 of the fraction x minus 1 over 2x plus 1 equals log base 9 of 3 over 4. Remember, guys, your condense step is required, all right? I won't give you full credit if you skip that step, because this is one concept that we condense and then we solve. So we solve by saying, oh, well, if log of this equals log of that, then this equals that. You're going to find that if one side reduce, or when you condense it, it creates a fraction, you're most likely going to have an equation where you cross multiply. So when I cross multiply, I'm going to have to do 4 times x minus 1 this way equals 3 times 2x plus 1 in the opposite direction. So 4x minus 4 equals 3 times 2x would be 6x plus 3. So we're going to solve for x, and I'm thinking bring the x's to the left or to the right. I'm getting -7 on the left. X equals -7 over 2. Boy, that negative logarithm makes me uncomfortable. It should, because if I plug -7 over 2 here, -7 over 2 minus 1's negative, and I can't do log base 9 of a negative. So my one and only answer was extraneous, so mark it out. And your result is on this one, there is no solution. Now here's another where you're going to have log of this equals log of that. Well, I've already got log of this on the left side, but I need to write this as log of, what's that? Condense it and make it 2 to the x. So again, we're constantly condensing. Then I can just say 8 equals 2 to the x. Oh yeah, 2 to the third equals 8, so x is 3. All right, that's not extraneous because I'm taking log of 8 and log of 2. I'm not taking the log of anything negative. Now let me show you the other way you could work this. Well, this is just x times a number. So couldn't you just divide both sides by log base 3 of 2? Algebraically, that should seem okay because those just cancel. It's absolutely okay. Log base 3 of 8 over log base 3 of 2. Oh, come on, you're not going to let me fool you with this, are you? Do you recognize change of base? And I know log base 2 of 8 equals 3. So 2 ways to do it. I would most likely do it the first way if I were left up to my own thinking. Now we're switching into the second kind of logarithmic equation. Well, on these equations, you don't have log of this equals log of that. So if you've got a log equation, you have to do something exponential. Just like if you have an exponential equation, you have to do something logarithmic. So never try to do something logarithmic to a logarithmic equation. Never try to do something exponential to an exponential equation. It's not going to work. So this is logarithmic. I need to do something exponential. Well, one thing I can do is called exponentiate both sides of the equation, which means the opposite of log base 2 of is 2 to the. So I can say 2 to the log base 2 of x equals 2 to the 1/3, like that. Now I know that 2 to the log base 2 of, essentially, they neutralize each other. So I just get x on the left. 2 to the 1/3 would be better written as cube root of 2, okay? You can do the same thing here. I could say, well, the opposite of ln of is e to the. So e to the ln of x equals e to the 5th, okay? E to the ln of x isolates x. E to the 5th is a weird, irrational number, but it is a number, so you're done. But there are two ways that you can think of this. You know, when we did exponential equations, we took logs of both sides and we rewrote in logarithmic form, and we got to the same point in the problem. You can do the same thing here. So I could say, let me take the logarithmic equation and simply write it in its exponential form. So 2 to the 1/3 equals x. That also gives you x equals the cube root of 2. So guys, if going to exponential form makes more sense than exponentiating both sides of the equation, hey, do it. Do the thing that makes sense to you, practice it enough to perfect it. So same thing here. If I say, well, let me just rewrite that in exponential form, the base is e, so e to the 5th equals x. So I get the same answer. Now, that might help on this one, but you got to know that you work from the outside in. So for instance, you might want to think of this as log base of something on the inside, log base 5 of something u equals 0. All right. Then can you rewrite this equation in its exponential form? I bet you can. I bet you would say, well, that means 5 to the 0 equals u. Now let's replace. What did I let u stand in for a minute? Log base 3 of x. And what is 5 to the 0? 1. Now how about you rewrite this again in exponential form? So 3 to the 1st equals x. Oh, x just equals 3. And that one's kind of a nice one to check because look, if you said what is log base 3 of 3, would you not get 1? And then what is log base 5 of 1? 0, okay? So you could also say 5 to the, and exponentiate this to start with if you like that method better. Now, we're going to go to an equation that sort of blends the two things we've talked about already. Number one, you can't have double or triple logs on one side of the equation, so you start by condensing to a single logarithm. So since it's an addition problem, do you see that I would condense by multiplying? So that means I'm going to have to FOIL x minus 3 times x minus 5. I'm getting x squared minus 8x plus 15, and that's equal to 3. Now, I want to either exponentiate this equation or rewrite it in exponential form because I don't have log base 2 of this equals log base 2 of that. So I can't just set the two sides, the two this and that equal. So I'm going to say, well, 2 to the 3rd power. So notice I'm rewriting in its exponential form. You could also say 2 to the on both sides if you prefer. Hey, I've got a quadratic equation. So that means everything needs to come to the right side in this case. So 2 to the 3rd is 8. Let me subtract 8. That means I've got x squared minus 8x plus 7. Okay, so let's try AC method. I'm thinking it's x minus 7, x minus 1. I double checked it. That makes sense. So x equals 7, x equals 1. I like to write them separately just in case I need to strike one or both of them out for being extraneous. So when you plug in 7, you would do log base 2 of 4. That's fine. And log base 2 of 2. That's fine. So 7's safe. It does not make me take the log of a negative or a 0. When I plug in 1, I do log base 2 of, negative 2. I can't do logs of negatives, So 1 is out. Now here, I've got the same scenario, but your answers are going to be stranger. So again, you can't have double or triple logs on one side of the equation. You must condense so you have one term on the left, one term on the right. So my one term on the left is going to be distribute 2x squared plus 2x. So ln of 2x squared plus 2x equals 1. So now what I need to do is exponentiate and do e to the, or simply rewrite in exponential form. So remember, it's understood base c to the first power equals 2x squared plus 2x. Oh no, how do you work that? Well, guys, that is just a quadratic equation. But with the c value being irrational, it's not going to factor. So you need to do quadratic formula or complete the square. I would lean toward quadratic formula here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's see here. I've got negative 2 plus or minus. This looks like it's going to be 4 plus 8e, I believe, all over 4. Now, I could actually simplify that a little bit, because if I factor out on the inside 4 and make it 1 plus 2e, do you see that's going to be negative 2 plus or minus, the square root of 4 comes out as 2 times the square root of 1 plus 2e, all over 4. Whew. All right, so guys, what I've got is negative 2, well, let's do this. Negative 2/4 is negative 1/2 plus or minus the square root of 1 plus 2e all over 2, because that 2/4 is also going to be 1/2. I'm going to write them separately. So I've got negative 1/2 minus the weird square root all over 2 as well. Well, this one's negative because it's a negative plus a negative, which means I can't plug it into ln of 2x. So that one goes. This one's going to be okay. My suggestion is, if you want to check your answer thoroughly, go ahead and get your decimal approximation for this, plugging it into the left side. Your left side will turn out approximately equal to 1. It won't be exactly equal to 1, though, if you round this at all when you plug in. We have 3 more equations which we're going to solve, and they are equations which are quadratic in nature, so you can use a dummy letter. I'll catch up to you with those 3 on the next video. So the next video will only be like 5 minutes long.